T-minus 15 seconds.
Out in the mountains of Promontory, Utah,
T-minus 10, 9.
A next-generation solid rocket booster from Northrop Grumman roared to life for the first time on June 26.
1. Fire. T-plus 5 seconds.
It's known as BOLE, or Booster Obsolescence and Life Extension, and this is the first engine fire test in a campaign supporting NASA's Artemis program. The test had mixed results. On the one hand, the booster reportedly produced more than 4 million pounds of thrust. That's 30,000 pounds beyond what was predicted at its max. On the other hand,
T-plus 100 seconds.
an anomaly seen toward the end of the planned 2-minute firing
The aft deluge.
Activated. Whoa!
sent part of the nozzle flying, not the ideal ending for this test that was years in the making. Hours following the test conclusion, Jim Kalber, Vice President of Propulsion Systems for Northrop Grumman, issued a written statement. He wrote, quote, "Today's test pushed the boundaries of large solid rocket motor design to meet rigorous performance requirements. While the motor appeared to perform well through a harsh burn environment, we observed an anomaly near the end of the 2+ minute burn. As a new design and the largest segmented solid rocket booster ever built, this test provides us with valuable data to iterate our design for future developments." The BOLE booster was conceived as an important step for the evolution of the Space Launch System rocket built for the Artemis program. If Congress rejects the Trump administration's push to nix the SLS rocket after Artemis 3, NASA intends for the BOLE solid rocket motors to come into the fold following the Artemis 8 launch. That version of the SLS rocket will be referred to as SLS Block 2.
We're looking more long-term with BOLE, the Booster Obsolescence and Life Extension program, where the Artemis 9 boosters will be new boosters. So we run out of shuttle hardware through Artemis 8, and so that test campaign is well underway, and we actually are going to do a static test of the BOLE motor next spring.
4-stage engine start.
As the world saw with the Artemis 1 launch in November 2022,
And liftoff of Artemis 1.
the current version of the SLS rocket uses boosters made from Space Shuttle-era hardware, which are augmented by using 5 segments instead of 4. They provide about 75% of the rocket's initial thrust and separate a little more than 2 minutes after liftoff. The next set of SRBs were stacked inside of the Vehicle Assembly Building at NASA's Kennedy Space Center in Florida ahead of the Artemis 2 launch, currently planned for early 2026. Before those boosters were fully assembled, NASA gave Spaceflight Now and others a chance to see the aft segments close up at a storage facility back in July 2024. That's where we caught up with Doug Hurley, who was, at the time, the Senior Vice President of Business Development within Northrop Grumman's Propulsion Systems unit. The former NASA astronaut described some of the key differences between the BOLE boosters and the shuttle hardware repurposed for the first 8 Artemis missions.
Some of the significant changes for the new booster is that the cases will be composite. The current cases are steel, obviously shuttle heritage steel cases. We're going to have a electronic thrust vectoring control system, which will be new. We've done some changes with the propellant, and then of course just efficiencies in manufacturing. I don't know how much will go into that particular static test, but a lot of those changes are going to be incorporated, and we're going to see where we are, and then ideally they'll fly on Artemis 9. You know, and the other big advantage is because of the weight savings you get from a composite case, you'll get about 5 metric tons of performance for SLS, so it's pretty significant.
The Demonstration Motor 1, or DM1 test on June 26th was the first of 4 planned for the BOLE program. In the aftermath of DM1, Dave Reynolds, NASA's SLS Boosters Program Manager, said during the official broadcast that the next 6 months will be spent poring over the data.
We push the margins on almost every material that we have, and that, I would suspect, is probably one of the first things that we are going to learn, is how close did we come to the edge of those margins. And if we did get too close to the edge that we're not comfortable, we've got other plans in place to move forward and build another motor that can teach us the things that we needed to learn from.
The DM1 test was not the first stumble for Northrop Grumman regarding its solid rocket boosters in recent months. In October 2024, An in-flight anomaly was seen less than a minute after the liftoff of United Launch Alliance's Vulcan rocket during its second certification mission. One of Northrop Grumman's graphite epoxy motor, or GEM, 63XL boosters experienced a burn-through of its nozzle, as seen in video captured by Spaceflight Now. Fortunately, the Blue Origin-built BE-4 engines, along with the guidance, navigation, and control system of the Vulcan rocket, were able to compensate for the anomaly, and the flight was able to achieve its orbital target. However, that issue resulted in a months-long investigation, delaying the certification of the Vulcan rocket for national security missions until March 2025. During a media roundtable in April, ULA President and CEO Tory Bruno talked about the anomaly and the resolution of that nozzle investigation.
Northrop Grumman, of course, did a great job. They stepped up and worked this the whole time very aggressively. We did isolate the root cause to a defect in a part inside the nozzle. I think it's okay for me to call it an insulator, because that are the only kinds of parts that are inside a rocket nozzle. We know how to screen for it, so we're screening for it now, and don't expect to see any of those issues in the future.
While both the GEM 63XL and BOLE solid rocket motors are manufactured by Northrop Grumman, they do have distinct manufacturing lines and materials. BOLE shares more in common with this subscale booster motor that was tested at Marshall Space Flight Center in Huntsville, Alabama in 2021, 2022, and most recently in 2023. This 24-inch booster provided more than 82,000 pounds of thrust, compared to the 3.97 million pounds projected for the full-scale BOLE booster. The 2023 test of this engine was designed to give engineers at NASA and Northrop Grumman confidence in the nozzle and insulation materials, quote, with the intent of improving the erosion resistance of the components.
Fire.
If the administration and Congress fund the future of the Space Launch System rocket beyond the Artemis 3 mission, time will tell when the next BOLE booster will fire up in Utah and when it will be integrated onto an SLS rocket for the Artemis 9 mission. Reporting for Spaceflight Now, I'm Will Robinson Smith.